video, I'm going to do two examples. I'm going to do this first one about vehicles and the horsepower for that vehicle, as well as the miles per gallon that they get. And then I'm also going to do this example on roller coasters in the United States that includes information about the initial drop in feet and the duration of the ride in seconds. So let's start with this question about the vehicles. So first thing I want you to do with your calculator is I want to make sure that you are able to actually calculate when we get to question C to find the correlation coefficient. And to make sure that shows up on your calculator, I want you to hit second 0, which is catalog. So second 0. And I want you to scroll down to the letter D's where it says diagnostic on. All right, so almost there. So this is a good thing to do if you are trying to find your correlation coefficient the way I'm showing you in this video, and you're for some reason not getting it, then make sure you're diagnostic on right here. So I'm gonna hit enter and then enter again, and now it's done. So now when I do my button pushing to find the correlation coefficient, it will actually show up. So if that's not working for you, then that's the reason why. All right, so the first thing I want to do is I'm going to put this data into my list. So I'm going to hit stat edit. And in list 1, I'm going to put the horsepower. And in list 2, I'm going to put the miles per gallon. All right, so now that I've got all of these in here, I'm going to make it a little bit larger so you can see it. And we want to create a scatter plot. Now, the first thing you need to make sure before you go and create your scatter plot is you need to decide what is going to be your explanatory variable, so your X variable, and which one is going to be your response variable or your Y variable. So in this case, you have to, what I do is I kind of do both sentences in my head. Do I think that the horsepower of a car explains the miles per gallon that they get? Or do the miles per gallon for the car explain the horsepower that's in the car? Again, there's not really a right or wrong answer. Probably with most of these that you'll do, there's probably an answer the AP exam wants you to move forward with. I'm going to just move forward with, because I don't know anything about cars, I'm going to move forward saying that the horsepower of a car explains the miles per gallon that you'll get. So I'm going to say that my explanatory is the horsepower. So I'm going to put horsepower or list 1 on my X-axis, and my Y-axis is going to be list 2. All right, so here's how we do it. Hit second stat plot. We're going to turn the first one on. All right, so turn it on. Then this first one here is actually the scatter plot. And when I look, I said my list 1 was going to be my X variable, and list 2 is going to be my Y. So now when I hit graph and then zoom stat, make sure you go down to zoom stat, or you can click the number if you know the number, which is 9. You should see our scatter plot. Okay, so this right here is the scatter plot for horsepower on the X-axis and miles per gallon on the Y-axis. Okay, so that's part A. If you want to sketch it, you can. I'm not that worried about it. Let's do part B. Part B says, describe the direction, form, and strength of the plot. Now, this is actually asking you to find those 3 words and write about them. What it probably will say on the AP exam is, again, you're not going to have to type in all this on the calculator, but if they give you a scatter plot on the AP exam, it asks you to describe the association between horsepower and miles per gallon. That's asking you to find direction, form, and strength. So very similar to what we did when we had our histograms for one quantitative variable, where you're asked to describe the distribution with shape, center, spread. In a scatter plot, right, beginning the work with linear regression, this is 2 quantitative variables looking at the relationship between them. You're asked to describe the direction, form, and strength. So when I look at this, what I notice is in terms of direction, it looks like it is starting kind of like the beginning is a little higher than the end here. So it looks like it is a negative direction. In terms of form, the most basic decision is, do you think this is linear or do you think this is not linear? All right, or curved. And maybe there's something interesting going on with this one, but I think by and large, and you're going to see the reason I do this in most of these, I'm going to say linear because, again, if you don't say linear, then all the stuff we're going to kind of want to do in the next couple of chapters, you can't do since the unit is called linear regression. So I'm going to go and say linear, even if this point here kind of worries me a little bit. It's pretty far to the right in terms of horsepower, but it's getting not super low miles per gallon. And then strength, the main words I'm deciding between are weak, which would be like very spread out, lots of more like a cloud. Moderate, which I'm probably going to say moderate here, or strong, and where it's very, very tight together, kind of looking very linear. What I would say is whatever I decide, once I calculate letter C, where I actually find the correlation coefficient, which measures the linear relationship between these two variables, I can always go back and change it. So I'm just going to pick moderate, but depending upon what I get with my letter R, I might end up changing it. All right. So with that all being said, let's go and write down kind of the answer here. I'm going to write down an answer for part B over here. All right. So we have the association. You always want to put it into context between horsepower and miles per gallon is negative, linear, and I'm going to say moderate. Again, you can disagree on these if you so feel the need. All right, so let's do letter C. This is asking me to calculate the correlation coefficient, which is lowercase letter r. So I'm going to go ahead and go back to my calculator. All right, so there's my calculator. And so I'm going to hit stat, calculate. All right, and so far, when I've gone to calculate, all we've done is one variable statistics, but now this is a completely different unit. We don't have one variable, we have two variables. But I'm not doing two variable stats. I'm actually going to scroll down to linear regression, but I'm going to blow by number 4 and go to the linear regression number 8, which says A plus BX. It's not really that big a deal if you pick 4 as opposed to 8. But in statistics, and again, this is like not a huge deal now in an intro stats course that we're in, but if you take upper level stats, we like to put the y-intercept first, so that A is the y-intercept, and then plus bx, and that b is actually the slope, which I know can be confusing because for years in algebra, you've been using the letter b as the y-intercept. So just to make it more confusing to you, we're going to use this one. So linear regression, A plus bx. It's also the way that you'll see it written on the AP exam, where you have the y-intercept first and then the slope. All right, so hit number 8. All right, my explanatory, my x variable is in the list 1. My list 2 is my y variable. So I'm just going to go down to calculate and hit enter. There it is. All right, hit it twice. Now, just to let you know, if you did not do that very first step in this video where I did diagnostic on, right, second 0, which is catalog, you got to go to diagnostic on and hit enter to actually, do that. If you don't, you're only going to see y, a, and b. You're not going to see r squared, which we'll talk about in chapter 8, and you would not see letter r, which is my correlation coefficient. So negative 0.869. Negative 0.869. Now, it's up to you on where your cutoff is. My cutoff is usually about negative 0.8, negative 0.85 for going from moderate to strong. So I would probably change this to be strong in terms of my decision on strength. I'm just going to leave it at moderate because I wrote that. But again, feel free to go back and change this to strong if you would like. Now, letter D. Write a few sentences telling what the plot says about fuel economy. So based on my scatter plot, which I go back to it here with my graph, it looks like in general, as you move to the right in terms of your horsepower, so the more horsepower your car has, I would expect your car to get less miles per gallon. Is that always true? No. But just in general, that's what it looks like when I look at this negative association. So I'm going to write down that I would expect that as the horsepower of a car goes up, the miles per gallon will go down. Now, I want to be very clear that just because two things are correlated does not mean that there's actually a cause and effect relationship. So that's why I'm saying I would expect, right? I'm not saying that it's guaranteed to happen. There are I don't know anything about cars, but I do know that a lot more goes into what your miles per gallon is for your car than just the horsepower of your engine. So that's why I'm saying that this is what I expect to happen. There will be cases in which that is not true. All right, so that's it for this first example with these cars. So now I'm going to shift to this next example, talking about these roller coasters, and it doesn't really say a whole lot in terms like this one had parts to do, but I'm going to do kind of the same kind of process. I'm going to make the scatter plot. I'm going to look to see how I describe the association between the height or length of the initial first drop and the duration of the ride in seconds. Then I'm going to look at the correlation coefficient to see if that tells me anything, ultimately leading to, does this allow me to say something about the relationship between the two? All right, so I'm going to go to my lists, so stat, and then edit. And what I'm going to do is I'm going to clear these out. So if you go up to where it says L1 and it's highlighted and hit clear and then enter, it will clear both of them out. Same thing here. So go hit clear and then enter, and they're both gone. So now I'm going to go ahead and input these values into my L1 and L2. You could have used L3 and L4, not a big deal, but I'm going to just go back to L1 and L2, just out of habit. Okay, so now I've got them in list 1 and list 2. And again, the idea here is before I go to my scatter plot, is I want to make sure that I've decided which one's going to be my explanatory and which is my response. So here are the two statements that I'm saying inside my head. Do I think that the length of the initial drop in feet explains how long the ride is? Or do I think that the length of the ride explains how long the initial drop is? And again, you could probably make an argument for either one. I'm just going to say that the length of the initial drop is going to explain the duration. So I'm just going to have L1, my list 1 is my X, and list 2 is my Y or my response. So I'm going to go to second stat plot. Remember, it's already on from my last one. And I have the scatter plot chosen, that very first one, and my list 1 is my X, and list 2 is my Y, so we're actually good to go. So hit graph, and then remember, hit zoom 9, which is zoom stat, and there it is. Okay, so it looks like if I were to describe this association with those three words, right, direction, form, and strength, it looks like it does look positive. Right, again, this point here in the far right makes it look a little less positive, but in terms of it does have a general positive relationship, which kind of makes sense, right? If the length of the initial drop is longer, it's probably going to take longer to finish the ride. In terms of linear or not linear, right, for the form, again, I don't really care which one you decide here. I would say linear, and then I'll teach you in chapter 8 some things to kind of check to make sure that it's okay to say linear. So now I'm just going to say linear, but I can totally agree with you if you say it's not linear, right? It kind of looks like a cloud. And then for the strength, I hope you see, as opposed to the one we did previously with the cars, this definitely is more spread out. I know there are less data points, but in general, the data points are more spread out than they were on the previous one. So I would say that this is probably a weak association. Again, your letter R can help you determine that. So I'm just going to write a little statement over here that kind of sums up what I just said there. So there is you'll notice I very much have a formula for how I do this. There is positive. Again, I'm going to say linear. I totally understand if you say not linear. Weak association between the length of the initial drop and the duration of these rides. All right. Now, to help me decide if I feel good about using that word weak or if I want to change it, I am going to calculate the correlation coefficient, just letter R today. I know there are other things that you see when I do this that we'll get into in chapter 8. So I'm going to hit stat and then calculate. Remember to scroll down to number 8 for linear regression, A plus BX. We're going to use list 1 as an X, list 2 is my Y, and so scroll down to calculate.
All right, and then we have our letter R, which is 0.352. So R 0.352, which my cutoff usually for weak, in order to get to moderate, I'm thinking you definitely need to be past, 0.5 or negative zero point 0.5 on the way towards strong. And this to me would not cross that threshold to get to moderate. So I think 0.325 is weak. So I feel good about that. So in terms of like, what does this indicate? Yeah, I mean, it kind of makes sense that the longer the initial drop is, that it would take longer. But because it's a pretty weak association, I already told you, like when I looked at the graph, I mean, it looks, yeah, maybe I could say it's linear, but it does look pretty weak and it's kind of like a cloud. So there's not really a whole lot I can say about this other than like, yeah, it kind of makes sense in my head that if the initial drop is longer, then it's going to probably take longer to finish the ride. But nothing is jumping out at me like, wow, these are very much correlated. It's a pretty weak correlation at best. All right, so that's two examples on how to do this with the scatter plots and correlation. And don't forget to try those links as well as getting ready for our quiz.